Welcome to The Art of Roughness, a look at the life and times of Benoit Mandelbrot. He showed us that bottomless wonders spring from simple rules, repeated without end. Mandelbrot challenged the rigid lines of Euclidean geometry, arguing that clouds are not spheres, mountains are not cones. Nature's reality exhibits a different level of complexity. Mandelbrot's wolf education, tutored by an uncle who despised rote learning, taught him to solve problems geometrically. He relied on his eye to transform difficult problems into simple ones. Joining IBM in 1958 offered him the, quote, freedom of the outsider. He used the computer, not as a calculator, but as a microscope to visualize mathematical universes never seen before. In his 1967 paper, How Long is the Coast of Britain?, Mandelbrot demonstrated a paradox. The length depends on the measuring stick. As measurement precision increases, the length approaches infinity because real roughness is fractal. In 1975, Mandelbrot coined the term fractal from the Latin fractus, meaning broken. A fractal is a shape that is irregular or fragmented at all scales, characterized by self-similarity. In 1980, Mandelbrot discovered that stray specks on his computer printouts, initially thought to be quote, bugs, were actually self-similar copies of the main shape. This was an intrinsic property of the universe, not an error. Mandelbrot rejected the traditional bell curve for finance. He showed that markets exhibit, quote, wild randomness, meaning crashes are not anomalies, but part of the fractal nature of risk. Fractal geometry became a theory for everything. Its principles have been applied across biology, engineering, art, and cosmology, demonstrating patterns from lungs to galaxy distribution. Fractals moved from monsters of mathematics to pop culture, influencing cinema, music, and aesthetics. The Frontiers of Chaos's exhibition, for example, turned math into art. Mandelbrot, the maverick vindicated, published his seminal work, The Fractal Geometry of Nature, in 1982. Despite early academic struggles, his legacy as a scientific outsider remains profound. Mandelbrot's work shows us that the infinite sea of complexity contains two islands: Euclidean simplicity and relative simplicity, where roughness is present at all scales. He gave us the eyes to see the second island. This infographic details the life and work of Benoit Mandelbrot, the architect of roughness, from his early life and wild randomness research to the fractal revolution and his Yale legacy. Here is a list of references and key works, including The Fractal Geometry of Nature and The Misbehavior of Markets, which highlight the foundational texts of fractal geometry.